Okay, so the water armor effect we have comes when you have an overpressure, when that and this happens when you have suddenly valve close or a pump trip. So generally speaking, here you have a closure of the valve, and you have to guarantee that your overpressure doesn't overcome a certain limit to prevent some rupture of the pipeline. And here in the below you can see some examples about what could happen when there is a big overpressure. So you have to ensure the safety of your pipeline, and usually you have some safety valves or accumulator to be designed to overcome and prevent this effect. So you have a general relationship that belongs to the calculation of this overpressure that is directly related to the density of the fluid, to the celerity, which is the wave speed. So we will see that is the speed of the wave. So the information about the overpressure that let's say goes from the point where the valves close and the beginning of the pipeline, and then is directly proportional to the variation of velocity in your pipeline. This is a simple relationship, but let's say in a transient simulation, you have to take into account the wave reflection and also the pipe friction losses and also cavitation. And with this simple theory, you are not able to take into account all these effects, and so you are able to simulate in a more detailed way using a simulation tool. Just to collect the information about the celerity, the wave speed is directly connected to all these parameters. So the liquid density, the bulk modulus of the liquid, the pipe internal diameter, the thickness of the pipe, and the Young modulus of the pipe materials, and the pipe restraint factor. So basically, you have to take into account also the information about the material of the pipe. So if you have a pipe more rigid or flexible, you have different behavior about the wave and in the calculation of the celerity and the and consequently in the calculation of the overpressure that comes in the water armor effect. The approach from a simulation point of view, you can use a 1D tool, let's say a system tool, in this case Flonex, which is a CFD tools that is designed for the simulation of the pipeline, and especially the water armor effect is one of the let's say the basic simulation that you can perform in Flonex. So it works. Flonex works with a network model, and it's sort of conservation of mass, momentum, and energy, and it takes also into account the friction losses of the pipes in your network. So you have a one-to-one connection between the P&ID scheme and the Flonex model. So you are able to represent in a lumped approach with lump parameter. You can link one-to-one the information about the pumps, about the valves, and you can describe all the pipeline. For example, for the pipe component, you are able to fill the information about the the geometry of the pipe, especially the wall thickness, the internal parameter, the length, the internal diameter, the information about the material of the pipe, so the Young modulus. So all this information are allow the calculation of the overpressure. Moreover, with the valves, you are able to simulate the different kind of valves inside Flownex, and especially for the water hammer effect, you have to fill the information about the closure of the valve as a function of time. So you can provide information about the closure of the valve, and you will have as a result a precise calculation of the overpressure. This is due to the fact that you have a direct link between the KV of the valve as a function of the opening. The kind of results that you can obtain from Flownex or 1D simulation, which is a 1D simulator, are the pressure and velocity waves. So a chart where you have the pressure and over the time, and you have the maximal pressure and all the frequency of the waves. So the maximal pressure, the frequency, and also you can take into account the mass fraction of the vapor that is created if cavitation occurs. So now we will have a look at some detailed examples about the water hammer, especially in the pump trip. This is an example of when you have a pipeline with a pump, with an orifice and all the pipelines and the different tanks to control the overpressure. And I can show you directly with Flownex. So this is Flownex interface, and you can run the simulation about the steady state, and then you can activate the pump trip, and you can see that you have a real-time simulation when you can simulate the pump trip. So you have the pump that goes down, and you have the generation of the pump trip in this diagram, where you are controlling all the different pressures all over the pipeline. And moreover, you have the calculation of the forces that is acting over the line. So you can obtain this graph as a real-time calculation. Then you have to, let's say, prevent the water hammer effect. So you have the possibility to simulate an accumulator. So you are able to introduce in a pipeline an accumulator and fill the information about the volume of the accumulator and the reference gas volume, and you are able to make design and dimension this kind of accumulator to prevent the water hammer effect. So this is a second example where you are able to, let's say, design the accumulator. And also in this case, we are simulating a water hammer effect, just suddenly causing a valve that has at the end of this pipeline. So the mass flow is going to zero, and we are able to have a look at the different pressures waves in the two cases. So this yellow line is the pressure that is monitoring in the pipeline, which is the first one, which is the pipeline without the accumulator, and the second one is the pipeline with the accumulator. So with different kind of accumulator, you are able to control the pressure waves. so you have a smooth pressure changes. So you are able also to link this water hammer effect to structural analysis, which is really important because you have to prevent the water hammer effect, but you have also to be sure that this overpressure is sustainable with the structure of the pipeline. So Flownex has a partnership with ANSYS, so it's able to make a direct link from the forces that are calculating on a band, for example, to the 3D model of a band, and you are able to, let's say, calculate in an ANSYS mechanical model the maximal pressure and see if this maximal pressure is sustainable with this kind of bands and the let's say the structure that is around the band that fix the bands on the ground. You can also perform a transient structural analysis, so having more details information about the frequencies that is due to these pressure waves, and you are able to make echo simulation with a transient structural analysis, which has been performed in ANSYS Mechanical, and you are able to make calculation about the stresses and check if the frequency could be, let's say, a problem or close with the modal frequencies calculated in ANSYS structural. So thanks a lot for your attention. If you have any question, please contact me at this email, and I will be glad to answer all your questions. Thank you very much.